Hello, everyone. Good afternoon. So I'll be having a session on DHIS2 to FHIR updates, what we've been doing lately, and also what's on the roadmap, what we will look more into in the upcoming months ahead. And I'm also joined here by Jose, who is our FHIR expert. And yeah, it's great to have you here. And we are hoping that at the end of this session, if you have time, there will be some minutes to have a discussion on the ongoing FHIR integration and if our roadmap strategies are viable. So yeah, as I mentioned, firstly, I will just talk a bit about what FHIR actually is. I reckon that most of you are already familiar with FHIR, so I will just briefly go through this and especially have a look at what kind of FHIR resources we are focusing on. And yeah, and also I will highlight the FHIR implementation guide and also have a demo of the app. And then for a use case, I will showcase the HISP Tanzania tracker for immunization. And I will show you how an actual logical model looks like when it's completed, when it's been generated from the DHIS2 metadata, and what kind of information you can get from such a implementation guide. Then briefly, we will have a look at lessons learned during our work with FHIR integration. And also I'll present some of the direct feedback we have got from testing out the IG generator app with different HISP groups as well. And then we will have a look at the available FHIR tooling, and we will also have a demo of a FHIR tool that we can use to map our IG artifacts, in particular logical models, to actual FHIR resources. So just one slide, what FHIR actually is. FHIR stands for Fast Healthcare Interoperability Resources, and it's these resources that are really the point of FHIR. I think there are over 150 resources now in the current spec, and these range from patient to observations to encounters and questionnaire to capture questions in a form, and so on. And it's a free and open healthcare data API, and it's designed to facilitate data sharing between different systems. And it builds on the experiences from earlier HL7 standards. And one of the major new things is the use of modern web standards, such that it should be easy for new developers to just grab it out of the box and get something up and running very, very quickly. So we have JSON, XML representation of the different resources, HTTP, RESTful API, and structured resources like patient. And the idea behind FHIR is that resources, as is, should like highlight 80% of all of the use cases. And for the last 20%, you have to modify the resources, and how you do that is with profiles. So different FHIR resources can either be constrained or they can be expanded in profiles to fit your local context. So for instance, this is just a FHIR patient resource, I think. Yeah. And as you can see, almost none of these elements are actually mandatory. So if you want to have some mandatory fields for your FHIR resources, then you would have to profile it. So for instance, adding that name is mandatory, but you have to capture the patient name. And if you want more information about FHIR as well, you can go to the link below, hl7.org/FHIR, and you will find an overview of all the different resources, the data types that are supported in FHIR, and so on. So just a simple line, FHIR is a set of JSON and/or XML health data resources, plus a REST API for accessing them and exchanging them. So why the focus on FHIR? Well, first off, it standardizes interoperability, and we see a lot of adoption of FHIR around the world. So FHIR aligns with WHO guidelines, and we also see the XT-EHR consortium coming along with the EU collaboration to like come together to define a shared healthcare collaboration using FHIR as well. And FHIR is also great for metadata governance and to, or at least we have found out that it's great for expressing our internal DHIS2 model in a very friendly way for implementers. And FHIR also comes with a lot of tooling support and, of course, a large community with experts as well. So when we started to look into the mapping DHIS2 to FHIR, we wanted to first figure out what kind of elements can we generalize, what can we automate when it comes to generating these kinds of FHIR artifacts. And one thing that we found out quite early is the use of logical models. So it's a FHIR way of representing abstract data structures. So you can use logical models to model the tracker model. And that's exactly why we're using it. So it allows us to model data elements and attributes from tracker. And we can include the cardinality of the data elements, the different data types, and the mappings as well from DHIS2 data types to FHIR data types. And the DHIS2 data types is actually a subset of the FHIR data types. So we can map all of the data types with no issue. And also we can include, if you have any constraints on the data elements, binding, what kind of option sets are used for your DHIS2 attributes or data elements. And you can also add example content to your logical models as well. And it does not assume a specific FHIR resource mapping. And it allows your data requirements to be described from a functional perspective. So here I have included a logical model for registering a client. So you can see this is the base data elements that are needed to capture client registration. So you have the unique ID, you have the name, sex, birth date, caregiver, and so on. And I don't know, Jose, was it you who authored this from the immunization example? Yeah. And another thing that I also want to pinpoint is implementation guides, which is like a rule book on how to use FHIR for a particular use case. So it contains rules, documentation, an example of proper use of your FHIR resources and profile. So, for example, which profiles should be included in order to comply with national standards. And also what kind of terminologies to be used for your implementation. So this can be SNOMED, CT, this can be ICD-10 or 11, LOINC, and so on. You can include all of your references to the terminology that you should be using. And it's both machine readable and human readable. And that's why, or one of the many reasons it's been or became a part of the SMART guidelines approach. So you can see that we have progressive layers, and on layer 3, we have machine readable recommendations of your guidelines, and those L3 recommendations are using FHIR and implementation guides. And this leads us into the IG generator app. So as I mentioned, we wanted to focus on things that we could automate, make it easy for the users to actually use the app. It should just be to press a button and you should get a list of some FHIR artifacts that you then can use to further map to FHIR resources. And interestingly, also, we find out that it was actually really useful for just exposing the DHIS2 tracker metadata in a FHIR-friendly way. So as you can see, here we have a tracker program and an enrollment, and the enrollment itself is mapped to a TB program logical model. So you have all of your tracked entity attributes listed here. And also for all of your option sets, you have code systems with all of your options from DHIS2 as DHIS or FHIR artifacts. So just to give you an idea of how simple it is to use this app, I will quickly go to the Play server and I will go to the app management app. And I believe that the IG generator app is already installed. If you want to install it yourself, you can go to the app hub and just install the latest version. And as you can see, we have it here. So first off, you are presented with the configuration form. So here you can set all of the configuration for your implementation guide. So for this example, we will just go ahead and use example IG. And we will use example. The status can just be draft. The version is okay, CI build. Use DHIS2 as the publisher, and there we go. And now you are presented with the tracker program selector. So based on your DHIS2 instance, the app fetches all of your programs that you have, and you can then just pick and choose what kind of tracker programs you want to express in your implementation guide. So for this example, let's just pick child program and TB program. And then you generate all of the artifacts, and then you can download the implementation guide bundle, which is a zip file. And then it's the whole step of actually publishing your implementation guide. We will skip this for now, but as you can see, you have all of the instructions here with the prerequisites, the step-by-step instructions, and so on. It's basically just to run a couple of scripts, and you're good to go. So after doing that and waiting a couple of minutes for everything to generate, you are presented with your implementation guide that is generated based on the DHIS2 trackers that you chose. So as you can see, this is very bare bones for now, but we will focus mainly on the artifacts. So let's just have a look at the TB program. And I might have to, there we go. So as you can see, we have a representation in a FHIR-friendly way of all of your tracked entity attributes. So we have the first name, last name, gender, and so on. We also have the cardinality, what kind of data type it is, if there are any descriptions or constraints, these are included as well. And as you can see for the gender value set, it's actually bound to the gender value set, which is based on the gender option set from DHIS2. So if we have a look, you can just see that it corresponds with what we have in DHIS2. So we have two codes, male and female, and we also get a system based on the canonical that we gave the IG during configuration and the display value as well. And all of this metadata is taken from DHIS2. And in addition to the logical models, we have also tried to generate some resources directly as well. And we have focused on questionnaires to represent program stages, and particularly the program stage forms. So if we have a look at the TB visit questionnaire, for example, you can see that we have a list of questions, and you should also be able to render the form. So the treatment card, choose file, and yeah, just a very simple overview. But this was only for the Sierra Leone database. So how does this actually look like for a real use case? And that's what we're going to look at now. So Bob and I contacted different HISP groups in order to try to get some feedback on how the IG generator app actually works out in the field. So we have tested it a lot on the Sierra Leone database and also tracker metadata packages, but there weren't any real metadata issues to be found. So we tried to use the app on larger systems that have actually have some historic data and have been used over time as well. And this one from Tanzania is one of those examples. The metadata here was surprisingly good. But if we have another look at the artifact summary and logical models, one thing that I really liked was the documentation and the description that they've added for what the program actually represents. So you can see that all of this has been taken directly from their DHIS2 instance. It has automatically been added here in the IG. And if we have a closer look at the client-based immunization registry program, again, as we saw in the other example, we have all of the different attributes, and we have all of the different option sets as well. And you can immediately see that they're using a naming convention for their option sets as well. So if we have a look at the ID type, yeah, you can see that they're all having the expected values. But in addition to just generating these artifacts, you can also use the app as a sort of metadata validation tool to check whether your DHIS2 metadata is actually conforming to the FHIR spec. And how we have done that is with the IG publishing tool, we are actually running the sushi validation on the DHIS2 metadata. And in that way, we can see what kind of option set codes are not matching the required FHIR spec and so on. And all of this information gets added to a quality assurance report generated by the implementation guide. So you can see here in your generated implementation guide that you have some errors and some warnings, but most of these are actually related to you not having a description field of your elements. So as you can see, it's a lot of stuff, and it's mostly just the same. So you have the option sets in your DHIS2 system is lacking a description. So we also got some other feedback from the other HISP group that we used for testing. So they tested it on their DHIS2 development instances. And to be fair, it was mostly very clean and good metadata. Only a few to non-validation errors that led to the IG app not working and we having to fix some of the metadata issues before we could actually generate the IG. Across the different HISP IGs, there were some metadata issues that were common, and some of these were actually talked about during the last session, and especially white space in option set options, which needs to be normalized. So you have to trim the option sets code. There are often that people have, there are some typos included. Non-alphanumeric characters in data element name is a big one as well. And as you saw with the last demo, the lack of description fields as well for certain metadata elements. So what we want to do now is to add more validation to the app itself, such that you don't have to generate the entire IG, download it, run the whole IG publishing process before you're able to identify what is actually wrong with the source metadata. So some feedback we've gotten from the IG generator app in general. It works well enough to generate a lightweight representation of the DHIS2 Tracker metadata. Some improvements that we need to look on is, as I mentioned, it's troublesome to have to download the entire IG bundle to run validation and publish the IG to be able to view the quality assurance report. You have to go through the entire step, and based on the size of your DHIS2 tracker, actually generating the IG may take quite a long while. So ideally, validation should be included in the app itself, which allows for, or we should also allow for configurable mapping. So choose which fields to include in the logical models. And the last one is the really main one. It's a high risk of stopping at the logical model level without a clear mapping strategy. So what we have is this IG, and we have some documentation of our DHIS2 data model. We have our logical models, we have our questionnaires and our code systems and so on. But then what? What's the next step? Because we haven't actually done any integration yet. We haven't mapped it to actual FHIR resources or FHIR profiles. So IGs doesn't mean that we have bidirectional integration with FHIR, but this has been our strategy to focus on the documentation part, on the metadata governance. We need a solid way of representing our DHIS2 metadata in a FHIR-friendly way, and use that as the jumping off point to start to map to more fine-grained FHIR resources. So We used IGs to define the structure, provide documentation. It does not provide the transformation logic right now. So yeah, we still need to map between the FHIR resources and these logical models that we have generated now. But since we have focused on logical models, we can actually use some FHIR tooling to help us with the next step. So we just need to make sure that our logical model is a good and proper representation of our DHIS2 data model. And if we have a really good logical model that we can map back to DHIS2, then we can use some FHIR tools with nice user interfaces and so on to actually map the logical model to what we need. So you can see that there are many tools available. FHIRly, I think you have to pay to use it, but you can use FHIRly to set up a FHIR facade that speaks FHIR in the front end, and it talks directly to your native data in the back end. Simplifier is a platform where you can publish and share your FHIR specifications, and the Fume FHIR converter is actually really cool, no-code FHIR conversion engine. So you can actually do data transformations without needing programming skills. But what we'll be looking at today is the Termex, which is a quite a new tool. It's an open source platform for managing terminology, designing FHIR-based models, and enabling data transformation to support interoperability. So if you, let's see. So if you remember our logical model on the TB program, it looks like this. And this has been generated based on the DHIS2 metadata. And what I've done is to include it in Termex. So let's go for the Termex FML transformation, and we can add our definitions. I hope you can see it okay. And I've already added the TB program, so let's just see. There we go. And for this example, we will just use patient resource. So I think I can go to this one, and we will need to download the patient resource. And there we go. Just call it TB program demo. And if we then go back to the mapping and then generate the base FML and open up the visual editor, you can see that we have our source TB program with all of our data elements, and we have our target. So now on the right side, we actually have a FHIR resource, and on the left, we have our automatically generated representation of our TB program. So now what's left is just to connect the dots, basically. So we can just begin. If we have a look at name, we have to add a new human name. And in our model, we have first name and last name. So given name and family name. So it first creates a new human name data type in FHIR, and then it gets pushed to name. And you can continue to do this for all of your source metadata. For instance, you can see that we have an address with the address data type. So you can see that a lot of the data elements from DHIS2 can be mapped to this address data type, and so on. So it just gives you a very visual and nice way to map your source logical model to actual FHIR resources. And as you can see, you can add extensions if you need to use it. You can add constant values. So just to clarify a bit more, I have a smaller example. I hope you can see it. Okay, so we have a code, sex, last name, and first name. And you can see that the code is used to create a new identifier for our target patient. As I showed you before, we have last name, first name being mapped to given and family in the human name data type. And then for sex, we use a translation. So we translate from the internal code system to the administrative gender, which is used in the patient resource. And then you can also, in this tool, generate mock source data and actually run it through the transformation. And here we can see we have created a patient resource with the identifier system that we set in our constant, and the value is the code, and the name has been created as well, as you can see. So it's just a really nice tool to do some of the next steps in the FHIR mapping process. So some of the things that are on the immediate roadmap is to compile all of the feedback from the different HISPs, testing out the app. We still have a couple of more HISPs, I think, that still need to actually do the tests. And then based on all of the feedback, we have to improve the actual logical model generation. For now, the logical models are quite simple. We would very much like to add a bit more metadata to it, like the ID and so on, and also to include metadata validation within the app, such that you don't have to download the entire IG and run everything before being able to see, I have a double space between two elements in my code. And one of the strategic priorities as well is integration of data from external individual level systems using FHIR. So we need to support this. Also, bidirectional mapping between logical models and DHIS2, and engage more with the broader FHIR community as well, I think would be really helpful, just to get some feedback if this is the right approach, if it's feasible, or if we should focus on anything else. And just to make it clear, what is not on the roadmap is to create a separate like DHIS2 FHIR expert wizard. So the plan is to focus on creating good logical models that we can map to and from DHIS2. And then you can use those logical models to then do the next step to map it to the different FHIR resources using the using some FHIR tooling support or doing it manually. So some key takeaways: the IGs and logical models give a strong foundation, which opens up the possibility of using external FHIR-to-FHIR mapping tools. we see that mappings are very use case specific, so it's hard to generalize and it is hard to automate the transformations to FHIR resources. So there are a lot of manual labor that has to be a part of this. And yeah, also it's important to have some FHIR metadata validation support as well, just to check your source metadata if it complies to the FHIR spec or not, because then you don't have to change it down the line. Yeah. And that was basically all from me. Thank you. So I see that we have a lot of time for some discussions as well. So please, if you have any questions, feel free. Yeah. Oh, there.
All right, thank you. My name is Habib Bushra. I'm from Ethiopia. I'm Minister of Health.
Sorry?
My name is Habib Bushra from Ethiopia, from Minister of Health. I'm interoperability lead, and we are working on the FHIR system, not with the DHIS2, but other systems. So my question is, I'm seeing the IG one, so I want a bit clarification on the implementation one. So, like, do we have a FHIR server, or like simply like are we like displaying it in a FHIR structure, the data? So now we are mapping it, yeah. So we're mapping with the FHIR standard that you showed us previously. So do we have like a specific FHIR server so that the data sync to the FHIR server, or is it simply like live structure into the FHIR structure?
Yeah, so we do not have any FHIR servers included in the IG generator app. So what if you were talking about the Termex demo, then when I fetched my resources, this was just from a demo FHIR server, which is used internally in Termex. But for our IG generator app and for our work on FHIR generation so far, we have not included a FHIR server within the DHIS2 architecture. Yeah.
Sorry. So means we like whenever we display the data, we display it in a FHIR structure, yes? So the data is put in a SQL database. The database is the Postgres, yeah? So the data puts as it, but when we want to like get the data, we extract it using the FHIR structure. Is it how it works?
Yeah, so far we are only able to extract the DHIS2 metadata, convert that to some FHIR artifacts, and that's what is happening under the hood in the IG generator app. So for instance, you have your DHIS2 program, which is then mapped to a logical model in the implementation guide. And you have, for instance, a program stage, which is then mapped to a questionnaire resource, for example. And that happens in the IG generator app. And the resources themselves and all of the FHIR artifacts are saved within the IG. Yeah.
Just a supplementary question. So I'm Hanan. I'm the HISP lead is Bangladesh. Actually, the supplementary question. So for term X, you using the FHIR server. So this is a demo FHIR server.
Yes, so this is a demo.
The real FHIR server, because in Bangladesh, that's the challenge. The IG, we are not still mapping fully our cases because we need to actually remapping with the FHIR server again. So if the term X is have a breezing some bridging, then we may try again.
Yeah. Jose, I don't know if you have. Yeah.
So first, using of a FHIR server. So what we are seeing here is taking the advantage, the unique advantage that DHIS2 has, that has a very solid metadata foundation, and using that to say, if we want to do FHIR, this is the way to do. So we take that metadata, generate the logical models, and from there we know how to map this to FHIR resources. So that the most obvious use for this is that we can have some TB data and be able to export that out of DHIS2. So that's basically, we are still a client. So we're not serving anything, we're just pushing out things as a client to a server, to a possible server. The other thing that we can see here is that that transformation might use or uses what's behind the scenes here, which is the FHIR mapping language and the FHIR infrastructure for mapping, where we create FHIR structures. And in order to validate and to execute and to design this and to iterate through these things, then we use a repository of resources and an engine that can run the mapping. That is Termex. That's the server that can do this. You have at least one other solution that can do the same thing, but it's like, I need a lab where I can test these things. That's Termex. In production, I don't think you would use Termex to do the real live mapping. You would use the mapping functionality of FHIR to just do that, but that would be like a Happy server or a FHIR server. They would have this infrastructure. Termex is more for development and for terminology hosting. So there's a bit of a design thing, which is mostly what we're talking about here at this moment. In a design mode, I make my implementation guide, I make the mappings, and then I say, this mapping is fine. Now let's go on to production. From now on, if anyone clicks that button, that's your integration magic. If you click that button, you can run all of this that you have designed before, and then you export FHIR resource after FHIR resource. So this is just, we are seeing, this is the foundation of it. Like, we know how the demo patient there maps to the FHIR patient. This is where we work with the Termex and the internal FHIR servers. After this is done, the design is done, then we say push it in production, and then it's going to be custom logic, or more ideally, FHIR mapping expression, and then you can run this on the available server. So the production server that you have, it will do the hosting and the resource management, integrity checking, and all those things. This is the precursor for that, which is how do we design those things that we can click a button and then have all of that in a FHIR format. And I'm realizing I should have given some context. All of these things, like the mappings and the logical models and the code systems, they are all things that we can say, if we do this in FHIR, we can put this on server A, server B, or server C. We just design it once and then we make it run in production. That's one of the good things that FHIR has about tooling and about potential. And that's why this approach of taking the metadata and making the logical models, the questionnaires, and the value sets and code systems, this works quite well for the DHIS2 as an easy way to export DHIS2. The converse problem would be when we want to import things.
Yeah, exactly.
Hi, thank you. Femke from Pharmexis. I have a question a bit more about the broader concept of using FHIR for interoperability purposes. Because right now what I see is the risk of doing this is that you are going to have quite a wild growth of implementation guides.
Yeah, exactly.
How you see your role in making sure that we get leverage FHIR for also minimal data models and minimization of data capital.
You want to answer that, Bob?
I think Joseph is going to answer it better than me. But I think what we try to encourage, I suppose, is that countries who have put it on their roadmap or on their blueprint that we want to promote FHIR in interoperability in the country, that in fact then they also have a next step, which is to develop, I guess, national profiles. Now, of course, there's always a risk you then have a proliferation of national profiles, and that's a big governance question. You can try to persuade folk to build on top of IPS, for example. You can try to adopt as much as being done within WHO. But I think it's always got to be attention because the local context's always got to be local. And one of the things I think what we've been attempting to do here is to sort of de-nerdify FHIR to a certain extent and say there's a division of labor. There are clever people in the world and they know how to do this stuff, and it's not everybody. So if every implementation of DHIS2 that runs Tracker is able to produce the IG with a logical model, from there you can put it on to people like Joe saying, because we know there are not enough of those people in the world, and maybe that is what will keep down the proliferation. Maybe but there are not enough people who have that deep FHIR knowledge. There's a lot of people who call themselves experts. They've been on a 2-month FHIR course, something. But what we want to be able to say is that we can produce you the logical model. Now you have a national FHIR profile for Ethiopia, for example, or Sri Lanka. If we can produce you our logical model as an IG, then it should be a geek job now to do the translations.
Yeah, great.
That is the most important question. So that it is going to be a mess, because if you ask 2 experts, FHIR experts, the best way to do this, you'll have at least 3 different opinions. So if you start with that, but if you have these logical models documented somewhere, and as Johan was mentioning, if you have these documented, if you have these FHIR artifacts, then you can actually do the validation. So you cannot avoid, I don't think it's possible to avoid that. Everyone will think exactly, will think in different random directions. For example, someone says, we have gender was male and female. How do we do gender transition? It doesn't fit in FHIR. Some people will say this is an extension. Some people say this is an observation, and that's a mess. For the first time, if you do it like this, then you quantify the mess. You can observe the mess. And then you can have indeed a governance question. Like you can have someone at the government level or sub-government level or in the room, wherever consensus is built. Then you can say, how far are we different from each other? That's the question that I think is going to happen a lot for DHIS2, because it's an organic growth. Everyone has their kind of model. Every tracker has their own perspective. But once you have it documented, then you can say, in 2 aspects, you say on the top level, why, if I get the IG out of that program, I have patient model like this, and if I get it from that place, why is there some slight difference? That's not for the programs to resolve while doing FHIR. That's for the programs to escalate and say, hey, we need to clean this up because it's going to skew the numbers, etc. And on the lower level, the same thing. Why is this being put as an observation? This one is being put as an extension. I think the only thing that we can try is to make this visible, like the validation, that always having the validation in higher level, like how many, and maybe doing some metadata quality, like how many duplicates do we have for the same thing? That's where things become interesting, but it's more of a procedural. And of course, if you say, our country has a reference information model, if you do that, great. Then you can say, whatever I'm doing, let's see if it aligns. Most likely, the information model of countries, for most of us, will be the DHIS2 information model that comes from this. So push it up. And then we push it up to the government, and the government will say, oh, right, we have these 2 things meaning the same thing, or we have a gap here. So the shorter answer is we cannot avoid that, but we can document, we can escalate this and say, this is how it gets solved, both on the technical level and on the, most importantly for me, on the semantic level. What do things mean? Because it's now documented.
Are there any more questions? Yeah, please go ahead, Jose.
I do not know how many people are using FHIR, but I was expecting something about IGs. I did not know what they were doing. This is just awesome. From a FHIR perspective, this is really, really good, because we are looking at FHIR has a long product. So someone has to think of definitions, someone has to make the logical models. But this work has already been done in many countries. This is what we have for value sets for patients and for patient gender, etc. So if we can use that and create automatically FHIR specifications that then we can export for validation, or export to create a national data set catalog, or export to create the national glossary of terms. That is a unique thing that DHIS2, it's because it's very strongly based on metadata. I think this is really an awesome thing, and I was expecting to see some IGs. I'm sorry I did not follow up closely, but like the ability to create IG after IG after IG, that's really awesome. I was impressed with that. Thank you.
I didn't actually answer your real question, which was about the IG proliferation. And I think the decision to produce the IG automatically from a tracker program, the risk of making gazillions of IGs is huge.
Yeah.
Except we made the very, very principled decision that we produce the IG, but only down to the logical model. The point of making that IG, and I don't think it's a problem if there are hundreds of them. The point about that IG is it's designed to be mapped against something which is standard. So the IG itself, it's actually not for interoperability directly. It's there in order to be mapped to. Hopefully, what is a much smaller set of IGs generally should be national standards related. So if that makes you feel better or not, so that's. The beginning of somebody else.
Okay, then I think we can wrap it up 2 minutes early. If you have any feedback or want to post some photos, please use the QR codes there. And thank you so much for attending.